Have you ever run your fingers across a seemingly smooth surface only to find tiny imperfections? These imperfections are called surface roughness. Surface roughness is a critical factor in engineering and manufacturing. It can impact a product's functionality, durability, and even its aesthetic appeal. Surface finish measurement equipment helps us understand these microscopic features. These instruments provide quantitative data on the texture of a surface. They measure the deviations from a perfectly smooth plane. This information is crucial for quality control and process optimization. Imagine a mirror. A mirror needs to be incredibly smooth to reflect light properly. On the other hand, a car tire needs a certain level of roughness for better grip on the road. Surface finish measurement allows us to achieve these desired textures with precision. Without proper surface finish measurement, products could fail prematurely. They might not fit together as intended. They could also wear out faster due to increased friction. Accurate measurement ensures products meet their intended performance and longevity standards. There are various types of surface finish measuring equipment available, each with its own strengths. These instruments can be categorized as contact or non-contact types. Contact methods like stylus profilometers physically trace the surface. A small stylus like a miniature record player needle moves across the surface. It records the height variations to create a profile. Non-contact methods such as optical profilometers use light to measure surface topography. They are ideal for delicate surfaces that could be damaged by contact. These instruments analyze the reflection of light to create a three-dimensional map of the surface. Another common instrument is the Roughness Tester. This portable device provides a quick and easy way to assess surface roughness. It gives a numerical value representing the average roughness within a defined area. The choice of instrument depends on the application. Factors to consider include the desired measurement accuracy, the size and shape of the part, and the material properties. Like many technological fields, surface finish measurement has seen significant advancements in recent years. Improvements in sensor technology have led to higher resolutions and faster measurement speeds. We can now analyze surfaces in greater detail than ever before. The integration of software and computing power has also revolutionized data analysis. Advanced algorithms can now extract more information from the measurements. We can now identify specific surface features and analyze their characteristics. One exciting development is the rise of three-dimensional surface profilometry. This technology allows us to create detailed three-dimensional maps of surfaces. This is particularly valuable for analyzing complex geometries and freeform surfaces. These advancements have opened up new possibilities in various industries. From aerospace to biomedical engineering, precise surface finish measurement is driving innovation and improving product quality. The benefits of advanced surface finish measurement extend across numerous industries. In aerospace, it ensures the aerodynamic performance and structural integrity of aircraft components. The smooth surfaces of turbine blades, for instance, are crucial for engine efficiency. In the automotive industry, surface finish impacts friction, wear, and noise levels. Precise measurements are vital for optimizing engine components and improving fuel efficiency. The texture of a car's exterior also influences its aesthetic appeal. In medical device manufacturing, surface finish can influence biocompatibility and device performance. The surface of an implant, for example, can affect how well it integrates with the body. Precise measurements are crucial for ensuring patient safety and optimal device functionality. As technology advances, the demand for precision in manufacturing will only continue to grow. Surface finish measurement will play an increasingly vital role in ensuring product quality, reliability, and performance across a wide range of industries.